I'm going to go ahead and jump into it and get started. First of all, thanks everyone for joining today. Really excited to be able to kind of share with this audience and talk a little bit about data engineering, how we see data engineering sort of playing in the enterprise today, and how things are really changing and how the world is evolving a little bit. Um, First off, I'll give you a little bit of background on myself and on the company. So my name is Demetrios Kotsikopoulos. I'm the CEO at Silectis, and we're really a company that's about data engineering. We've built a platform around data engineering. My own background includes stints doing data engineering work hands-on, perhaps as recently as today, as well as obviously working as a software engineer and a technology executive at various points. And really, this is obviously a subject that's kind of near and dear to my heart. Hopefully I'll be able to share some of the lessons that we've learned. I don't want this to be so much, a pitch for our product, as really just an opportunity for me to talk a little bit about some of the phenomena that I've observed as we've kind of interacted with clients, as I've interacted with my peers, and a little bit of, some of the lessons learned that we can share around data engineering, how data engineering is changing, and how a modern enterprise can succeed in the area of data engineering. So there are a few key themes that I want to talk about today around data engineering and the data engineering space. First off, data engineering really does impact everyone. It kind of touches every part of the organization. It really spans all kinds of different organizations. And the reason for that, and I'll dive into this a little bit more later, is because we're all sort of heading toward a world where we are more data driven, where decision making is increasingly oriented around data and sort of empirical evidence, and because to some extent we all are data engineers in sort of our daily lives as business professionals. Right. Whether you're a data scientist or whether you're, a line manager, you might be spending some time in Excel trying to join together two different data sets or trying to figure out how to build the right pivot table to see the data that you want. Or you might be, doing more advanced, using advanced statistical techniques to do feature engineering. Either way, in some sense, you're sort of interacting with the data with an aim toward preparing it to be effective for analytics. The practice of data engineering is evolving relatively quickly. Data engineer wasn't a very prevalent job title, let's say 5 to 10 years ago, and it's starting to become much more prevalent now. And I think that's because there's a recognition that this is sort of a discipline and that there's some, kind of unifying philosophy behind it. And finally, getting data engineering right really does demand a holistic approach. And what I mean by that is, in the past, we might have thought about ETL or to get data from source systems into databases, or we might have thought about, database administration to make sure that the operational environment is right and that we're getting the kind of performance that we should be getting. All of those different pieces really need to lock together in a way that's reinforcing to succeed in a world where things are just changing more rapidly and some of the demands on data are more diverse and more challenging. So what is data engineering? Data engineering, or at least the definition that I'm going to use for the purposes of this talk, is the practice of integrating and organizing data to support decision making. It's a little bit narrower than, let's say, responsibility for all of the data inside of the enterprise, but really thinking about this with an aim toward analytics. And what that really means is, there are kind of 4 key components that we like to think about when we talk about data engineering. There's this exploration component up front, and I think this is something that gets a little bit underplayed sometimes when people talk about data engineering. There is, getting an understanding of what the data content is, starting to get a feel for what the semantics of the data are, starting to understand, from a more purely mechanical standpoint, how much data is there, how much of that data is usable, where are there potentially quality problems. All of that involves exploration, and that exploration is really integral to the process of preparing data for analytics and to doing the next piece, which is really defining the target structure that you're going to aim that data toward, and building the pipelines that sort of transform and refine that data to get it in shape. That organization step and that exploration step are really iterative. There's a lot of back and forth there, and ultimately getting to the right shape for the data, kind of outbound, depends on understanding the data and understanding how people want to make use of that data. Once you've kind of got that data set, and obviously this isn't a linear process, all these things sort of happen in overlapping ways, governance and management are really important. And what that means is we need to be able to manage access to the data. We need to be able to provide a directory to that data that's accessible to the people who need to have access to it. And we need to understand how that data is being used. We need to understand its provenance. We need to understand where it's being distributed. All of that requires a management layer that sort of sits atop this set of structures and helps us kind of have some transparency into what's happening. And then finally, all of this needs to be operated in an ongoing way. And that means, scalability from a systems perspective, being able to handle additional data volume. It means managing the configuration and managing the infrastructure in a way that's controlled, and being able to do things like automate deployments and getting that sort of DevOps, data ops set of functions working. So that's sort of the broad sweep of what we talk about when we talk about data engineering. And as we kind of dive in a little bit more, these things haven't necessarily been thought about as a unified whole in the past. I know that 20 years ago, data modeling might be kind of a top-down exercise that is happening in some centralized organization, whereas the ETL process is sort of a thing that happens after that design process has largely been completed. Those things really need to happen kind of in lockstep in order to be successful today. And I'll touch more on that a little bit later. By the way, if you have any questions, you can use the Q&A. You can click on that Q&A icon and enter them there. I'll periodically kind of take a glance at those and answer them, kind of throughout, and then we'll have some time for a Q&A at the tail end of the presentation. So why is data engineering important? Kind of why are we all here? Obviously you all have some interest in data engineering and are excited about it. Otherwise you wouldn't have shown up for the talk. But another, the two big reasons, at least in my mind, are one, it's foundational. You can't do all of those downstream things that we're all very interested in around, getting insight if you don't have a solid foundation of data engineering as sort of the bottom of the pyramid. The other part of it is that it's got broad reach. From an information technology perspective, obviously, the IT team are often the practitioners of data engineering. They're the people that are responsible for delivering against it inside of the organization. And it's a tough problem. It's a tough problem because the technology landscape is moving pretty fast. It's tough because folks are constrained by their budgets and they don't necessarily have unlimited resources to address this problem. It's tough because there's, the current team might not match up with current needs. And we all probably know what it feels like to try to recruit data professionals today. You've got the analysts and data scientists who are the downstream users of this engineered information. And they're challenged because they're not necessarily getting the data in the shape that they need, and they're perhaps having to invest a lot of their time in getting the data organized and in refining the data. And then you've got business leadership and sort of the business users of data and the folks who are reliant on this insight. Executives today are relatively data conversant. They typically will have follow-on questions when they're presented with some set of data. And I think there's a certain level of frustration that people feel when they can't get those answers fast enough, or when every new question feels like a project. And there's also concern around investment levels in data infrastructure and in data architecture. So, everybody is sort of thinking about these problems in one way or another and is impacted by them in one way or another. So, I think it's an important thing to address, and it's becoming increasingly important as data becomes more central to the operation of most, if not all, businesses. So data engineering is also changing. I would say that 10, 15 years ago, folks thought about data engineering largely as an exercise in ETL. And even now, when I encounter folks who are responsible for data engineering, it feels a lot like an ETL function in a lot of organizations, where things like the design of the data repository, the modeling, and some of those other functions kind of tend to live somewhere else. But really, data engineering is a little bit more than that. Today, it's really full stack in the sense that data engineering kind of needs to own the shape of the target structure, needs to own some aspect of the operations. In the same way, the analogy I would use, in the same way that software engineering teams have increasingly taken control of the infrastructure and of their deployments. I think that the same trend is happening on the data side, where there's not necessarily a hard wall between DBAs who are operating the databases and data engineers who are serving up the data. In the past, I think we really did have to design around system limitations, and what I mean by that is we started building star schemas to support business analysis, both because that kind of dimensional model is actually a really good model for asking kind of routine business questions, but also because it had very specific performance benefits, and it allowed us to overcome some of the challenges of building repositories for analytics data that were really imposed because we had limited storage, and storage was expensive. We had limited compute, and compute was expensive. We needed to be able to sort of reliably do capacity planning a couple of years out. Making changes was hard and expensive. So, we really, in a lot of cases, the solutions that we were coming up with were informed by these technology constraints that were pretty rigid, and led to a very sort of an emphasis on kind of future proofing. And on bending to what we needed to do from a technology perspective, rather than really allowing ourselves to sort of think about what the answer is and how do we create the most flexible kind of platform to deliver insight. The other piece of it is, there was an implicit assumption that the workload was going to be predictable and that it was going to be constrained. And again, that's kind of baked into the old school way of thinking about data warehouses, where it's, we're going to design a model top down. It's going to be a really clean dimensional model. We're going to step back from that and build an ETL process in a tool. And then when changes happen, we're going to have a change control board that approves those changes. There might be different owners for different subject areas. And, there's a pretty substantial amount of latency between when you want to start making a change and when that change can actually happen. I think in today's world, particularly as data science has taken hold and become really mainstream, we need to have scope for experimentation and for the ability to fail. It's kind of baked right into the definition of data science, right? Data science is about empiricism. You can't know up front whether a model is going to work or whether it's going to be effective. And so being able to experiment and being able to kind of fail fast is important. And what that means is we might need different channels for different kinds of data that allow for more flexibility and more improvisation in the way that that data gets built out. So, I talked a little bit about how there are those, those technology constraints that we used to really think hard about. And they had to do with storage. They had to do with being, kind of resilient to changes. They had to do with being constrained by our ability to change the infrastructure. There are a few things that really are driving now that we need to just be aware of in the back of our minds as we think through how are we going to build our technology around data engineering. First, we need the atomic data, we need the detail, and we need aggregated data. Just capturing aggregate data isn't enough. that atomic data might need to persist for longer. And there are a few different reasons for that. One is just, data science kind of demands it and you need it. The other piece of it is compliance and regulation. You need to be able to, tell people what you know about them. You need to be able to retain data for certain periods of time for particular regulatory compliance reasons. And then finally, as you're deploying models into production, you oftentimes need to have an audit trail for how that model was built, particularly if that predictive model or if that scoring model has the potential to appear biased, right? There needs to be some way to trace back how was that model trained. The pace of change is just faster. It used to be that you really could sort of design for the current environment and there wouldn't be that many new systems or that many new data sources introduced. Now the pace with which new data comes in is increasing. There's more and more instrumentation kind of out in the world. So the shape of the data and the kinds of data that are available tends to change more frequently. And obviously that need for experimentation to support data science is really important. And then finally, this is more of an enabler than a driver. The public cloud and sort of cheaper compute and more flexible compute gives us more options. So, that kind of siloed approach that might have existed in the past where you had, again, a data architect that was thinking about the star schema or the snowflake schema and designing that as separate from the people that were responsible for the operation of the database, separate from the people who maybe had decision authority about what went into the database. Those things being kind of broken up introduced a lot of latency into the process and was sort of necessitated by having this more static architecture. And now we've got a little bit more freedom. And that freedom kind of manifests itself in the form of like, hey, you know what? S3 storage on AWS is pretty cheap. And, I can store as much as I really need to store as long as I have a way of getting at it from a compute perspective. I've got more choice of tools in terms of the way that I use and transform data. I've got more kinds of people that are touching that data. Data engineering needs to be sort of embracing those kinds of changes as it increasingly gets defined as a discipline. So we shouldn't be looking to, kind of bottle up the kind of flexibility that exists today. We should be thinking about how we can really enable that. And, that kind of gets to, some more concrete advice around, how do we now handle this? And I think there are kind of three big things that we can think about. First is really right-sizing the solution for your organization. Like I said, we have a lot of choice when it comes to technology today, particularly with what's available from our cloud providers, with what we can get from the open source community, with what's available from commercial vendors. We have to think realistically about what it is that our organization can sustain, rather than necessarily going for the best piece of technology in each particular lane, or the most advanced piece of technology, or the most powerful piece of technology. The second one is, like I mentioned, we're living in a more integrated world, and that means that we need to be able to create the conditions for collaboration around data engineering. And what that means is having windows into the data engineering process that stakeholders can use. It means having easier ways to communicate and share. And it means, kind of being built around having successful positive interactions with the business, with the analysts that are trying to use the data, with the application developers that are building out those source systems. If we can sort of build the architecture in the right way, we can facilitate that rather than having barriers to it. And then finally, we need to bring it all together. And what I mean by that is we need a set of tools that operate together with less friction than might have existed in the past. Or at the very least, we need to know where the seams are and how we're going to kind of bridge those things when we have multiple different tools that we're trying to use across our architecture. So what do I mean by right sizing? In this case, it's really thinking about the context in which you're living as, as a data engineering manager, as an IT leader, as a practitioner. Three big pieces to that. The first is just the economics of the solution, right? You have to live within your budget. And what that means is you're not necessarily going to be able to afford the best commercial version of each tool that's out there. And you're not necessarily going to be able to pay 5 different vendors to kind of manage that architecture for you. An example that I'll put out there is, when you think about data governance, perhaps the kind of Cadillac solution there is getting an enterprise catalog, enterprise metadata repository. That can be expensive, and it's just very difficult to implement if you're sort of resource limited. You don't have the right expertise on your team. So, think about what's sustainable in your organization from a budget perspective. And the other part of it is, you're going to need to be able to demonstrate some kind of an ROI. And what that means is, hey, if we invest in technology and build a better platform for data engineering, we're going to be able to save X hours for our analysts and for our data scientists. Or we're going to be able to, deliver insight X amount faster. And it's actually not that hard to build that case if you're really thinking about how your processes change or how you can accelerate once you start implementing a better answer. People, I think this one's really important, and again, gets perhaps too little attention inside of organizations. It is very difficult to recruit talent. And also you have an incumbent team that you probably want to get the most out of. People are willing to learn, people are willing to grow inside of their roles. So, what does your current team look like, and how can they grow to support a more modern set of practices around data engineering? What are the new tools that they can learn about? How does this become beneficial to them as you start to roll it out? If you need to go outside of the organization, what kind of talent is available in your market? And what that means is it's not necessarily all about geography, right? We're living in a world where a lot of us have gone distributed and virtual. Even so, that doesn't mean that your company, your particular team, can go out and get any talent that they want that's out there. So again, as you look at what are the different pieces that you're gonna grab off the shelf to build your architecture for data engineering, what can you realistically source talent for? And the example I'll give is you might have a framework like Flink. That's a great framework for streaming analytics. But realistically, how many Flink engineers who also know Scala are there out there? And are those people going to, do you have the kind of problem that's going to excite those people and is going to draw them into your team? And if you do want to draw them into your team, are you able to compensate them at sort of the market rate for people with that particular skill set? So, again, be realistic about what kind of talent you have access to and what you can afford. And then finally, who can you partner with? Are there vendors or consulting organizations that can help you fill the gaps, either on a temporary basis as your own team gets up to speed, or on a more ongoing basis in kind of a partnership mode? And then finally, from an architecture perspective, and this one's kind of obvious, your technologies all need to work together. They need to be able to interoperate. So, the idea is, make sure that you're picking things that work with the technology that you have and that you're able to leverage some of your existing investments. This next piece around collaboration is really important. And when I talk a little bit more about, our platform and some of our experiences with customers, this was something that was, that is more important than I kind of expected it to be going in. And that might've been, my, kind of short-sightedness on my part. But the thing that I've seen is being smart about how you enable collaboration, both within the team and across teams, can yield really substantial benefits. So when we think about what do we need for collaboration from a technology perspective, and I'm going to narrow down the conversation a bit, the things that we need are kind of centered in 3 areas. The first is user interface, and sort of how is it that we enable interactions with the data and with pipelines and with, with the inputs. The second one is the catalog, right? How do we provide a view into what data is available? across the organization to make sure that everyone has the same view and that they're finding the same data. And then finally, security. And security is a big enabler for collaboration for the reasons you would think. You can't share data without providing some constraints around who's able to see it and who's able to use it. So when we think about user interface, this is an area where I think there are a lot of interesting things happening and some unexpected things. You know, if you think about kind of the way that people have traditionally done data science or the way that people have traditionally done ETL, a lot of it has been desktop tools and desktop authoring environments where they were producing either, you know, notebooks in, you know, kind of desktop Jupyter that were maybe a little bit hard to share, that were leveraging data that was sitting in the same machine. Or, you know, on the ETL side, they were developing some kind of a configuration for an ETL pipeline that was pretty opaque and kind of hard to share, hard to read. You know, the example I'll give there is if you use a tool like Pentaho, for example, it spits out a really complex JSON or complex XML configuration, and maybe there's some Java that's baked into that as well, and it can't really be revision controlled because it's not sort of human readable and it doesn't make sense to diff the files. So the idea is, you know, how do we create an environment that's more amenable to sharing? In our case, the thing that's worked really well is using a web-based notebook interface, and that's what's baked into our tool. And that's, I think, things like Jupyter Lab, you know, more broadly in sort of the Python ecosystem work well for things like that. You know, thinking about being able to create a narrative with the data based on a notebook, I think is very useful. Being able to share analyses and share results is also enabled by things like notebooks. And on the other side, you know, there are, you know, kind of shared environments for data analysis from a BI perspective that are also, that have also, you know, kind of emerged over the last few years and have become more, have become a little bit more accessible. From a catalog perspective, you know, knowing where the data is and knowing what the current version of the data is actually, you know, kind of more challenging, I think, than people give credit for. You can have, you know, one centralized database that everyone is using, but if you want to really leverage the cloud and leverage more distributed approaches, you do need something that gives people pointers into the data that's available and make sure that folks are able to, you know, kind of share that derived data or the prepared data that they're creating. You know, so you might have a full refined set of data that's ready for the data science team. Let's make sure that they're all looking at the same one rather than everybody, you know, getting their own separate file download from wherever it is that they believe they should be getting it. And then finally, from a security perspective, like I said, it's about setting the right permissions. So, you know, the idea here is let's not allow the technology to sort of stand in the way of collaboration, and nothing makes it harder to collaborate than having, you know, a set of analysts and a set of data engineers who are maybe each using a separate desktop SQL client to query a Redshift database and are, you know, maybe cutting and pasting queries into, you know, into Slack to you know, create, to kind of collaborate with one another. Having a shared, you know, web-based environment where people can actually share out their specific analyses ends up being incredibly powerful. You know, an example of that is at one of our customers, we've got data analysts who use our platform and then share their notebooks with the data engineering team when they have data issues. And that makes that whole communication just a lot smoother. And then finally, is just this idea of bringing together all of these different pieces. And this gets to the, you know, kind of holistic approach to data engineering. And, you know, kind of, again, with an emphasis on the technology, there are probably about 4 things that we need to be thinking about. One is just what is that user interface? And that's, you know, potentially a notebook UI. It might be command line tools. It might be, you know, more traditional BI tools, APIs and, you know, other mechanisms for sort of doing system to system sharing. All of that needs to be thought of. It doesn't mean that you need to, you know, provide everything all at once and give everything equal priority, but, you know, there's a little bit of a checklist that you can go through when you're thinking about what you need. From a management and governance perspective, you might need catalog, you might need lineage, you definitely need security, You definitely need some way of building pipelines, and you need some kind of monitoring so you can understand what the state of the system is, and you can understand how your pipelines are executing. Right. So the idea is, think through what that set of management services is that you need in the middle. And that might be, let's take catalog, for example. That might be a more formal, metadata repository that gives you a lot of kind of powerful tooling, or it could be a wiki that just tells people, hey, here are what the data definitions are. Here's how you can get at it. Here's the right way to access this. Think about what will work in your organization. Think about the scale of your team, and then think about what it is that you need. From a compute perspective, there are a couple of different areas to think about. One is just, if you are operating at a scale where you need a distributed computing environment that can scale, there are tools like Spark, which we use in our platform, or Dask, which is kind of emerging in the Python ecosystem. Flink is something that was probably more current a couple of years ago. And you need to think about, how are you deploying in the cloud? And that could be just using VM instances that your cloud provider gives you. It could be using a separate container layer to sort of support that. But again, you've got to think through what your deployment approach is from a compute perspective. And then you've got to think about your storage. And that could be, distributed file systems, things like just, actual HDFS, or things like S3, Azure Data Lake Storage, Google Cloud Storage, that offer a pretty cheap, very durable, and sort of reasonably performant way to store a lot of data and get at it through these tools. So, the idea is, what are your repositories going to look like? And, databases are still there. One thing that we see a lot is an analytics database, something like a Redshift or a BigQuery, sort of sitting alongside something that's more data lake-like in terms of the underlying storage. So, think about the entire stack, think about what you need to prioritize, kind of what you need now versus later. And then think about what are the hooks that you kind of want to leave to plug into later on. So that's kind of the high level view. Big takeaways are really around just, making sure that you're thinking about the problem as a whole, making sure that you're kind of moving on from some of the constraints that might have been more prevalent in the past around systems, and think about how you're enabling collaboration and letting all of these different stakeholders sort of play. And that gets down to technology, but it also gets to process and setting up the right communications channels between teams and creating kind of a collaborative mindset. Tools can sort of facilitate that, but they might not be able to sort of solve it on their own. So with that, I'm going to just transition briefly to talking about kind of what we've done within Silectis and how we've built our own platform, and what are some of the things that we've kind of learned from that. So, I've probably said the word holistic 40 times in this presentation, and we've built a platform around data engineering. It's called Magpie. It's in production with quite a number of customers now. And the thing that we've done is really pull together some of the key elements of a solution in one place. So all of those core services that I talked about, we've kind of built them into one package. That's a great solution for some kinds of organizations. It might not be right for everyone, but we have a strong belief that if we can help reduce the technology complexity by pulling together the right pieces in one place, we can really help companies get to the right answer faster. It lets you have kind of one point of accountability around the technology, so that you're not trying to chase down 3 different vendors when something goes wrong. And there's some economies in only implementing one tool because you're avoiding a lot of integration cost. So that's kind of the pitch. If you're the kind of organization that's suitable for us, those are things that are going to be kind of meaningful to you. The other thing is we have kind of a code-oriented approach. One of the things when I was pulling together the company that I felt was important and I felt wasn't working well with other solutions, point and click tools for data integration, for database design, felt like they were actually a little bit of a decelerator. They were, it's annoying to have to click through like 5 screens of a wizard when you can just write a short script that can do that job. And so the idea was, let's build a tool that is code oriented, and let's let engineers be engineers. Most engineers aren't afraid to write a script. They're not afraid to write SQL queries. SQL is a great language for doing data transformations. So we've really zeroed in on using our own scripting language that's focused on doing configuration for data engineering, SQL, and then support for other languages like Python, R, and Scala to fill in the gaps and do things that might require a more kind of programmatic approach. But the idea here was let's allow data engineers to work in a way that they're comfortable, and let's provide a familiar set of tools that'll let them be productive. And what I mean by that is, there's a lot of people out there that know SQL. There aren't a lot of people that know, perhaps the proprietary, ins and outs of Talend, for example. So this is the platform that we built out, and it is about sort of facilitating this iterative loop that kind of sits in the middle here, with ingestion of data, exploration, refinement, and kind of rinse and repeat. We have our own catalog that sits in the middle of it and really does 2 things. One is it does provide those pointers for users that allows them to sort of find the data that they need, but also captures a lot of the exhaust of the data engineering process so that we're adding more context to the data. So we automate data profiling. We're able to track lineage. We're able to apply security. We have very detailed audit logging. All of those things are enabled by just having a rich catalog that sits in the middle. And then we've got a security and governance layer that surrounds all of that. And then we've got integration with the cloud infrastructure providers and, as I mentioned, a web-based notebook UI. So, again, this was us leveraging the experience that we have to build the kind of platform that we would want to use. And for the class of customers that we serve, this has been pretty successful. It allows you to access the underlying Spark layer. Spark is kind of our processing engine, while still giving you a set of higher level tooling that lets you get productive really quickly. Going a little bit further here, our domain specific language, this scripting language that we've used, makes our configuration really transparent. You can kind of see how the environment's configured and change it pretty easily. And the metadata repository lets us add more and more context to the data. And so that's, again, we're a platform vendor, so not necessarily suggesting that this is all stuff that you should go out and build, but there's something to being able to have control of your metadata repository. And if you're inside of a very large enterprise that can afford the investment, it might even make sense for you to do something that's really specific to your domain. But for us, having control of the metadata was really a keystone element in being able to build something that allowed us to serve our customers better. And then that domain specific language lets us just really add new features quickly. So, when we want to add the ability to, create a new schema from a database that we've just connected to, within our environment, we can turn that into a one-liner instead of having a, sort of a multi-click wizard. So that's been really helpful for us. The big takeaway for me has been, having the metadata repository kind of baked in was really invaluable. Bringing together all of those core pieces in a way that makes it easy to get up and running has also been really valuable. Again, it's the classic argument of best of breed versus choosing an integrated vendor package. But we've had success with it, and we've been really pleased with the kind of impact that we've been able to have at customers. Big lessons learned here. Just kind of what I've seen that's been sort of surprising to me. Collaboration outside of the data engineering team has been an area where there's been really some good incremental value that wasn't necessarily visible from the start. We have data analysts and data scientists inside of customer companies that are using our platform, and what it does is it gives them a view into the data lake that they can easily leverage. And it also just gives them a common language and a common platform with the data engineering team that makes it easier to iterate, easier to communicate. The data exploration piece and baking that right into the platform was also really powerful. We have, inline data visualizations in the notebooks. We have automated data profiling. Again, that's a really time-consuming process. If you think about, getting a new data set and the kinds of queries that you typically run, being able to automate that is really, really useful. The other piece is SQL plus some Python is a really powerful combination from a data engineering perspective, particularly if you back it up with a true metadata repository and some tooling like profiling, like the ability to specify pipelines, like a scheduler that lets you get up and running really quickly without having to reskill your entire team. If you've got folks that are pretty capable at SQL, you can get them productive pretty quickly. So that's been neat. The collaboration piece, I think for me, was probably the most interesting thing that happened that I might not have expected. I would have thought that we would have lived primarily in the data engineering team. But, even when people outside of that team aren't using the tool directly, even if business analysts aren't writing their own SQL queries, being able to use notebooks as a presentation mechanism for them has also worked pretty well for some of our clients. Again, in a way that was not entirely expected. So a little bit of tactical advice, and then we'll have time for Q&A. I saw at least one question come in. Tactical stuff, really look at your capabilities, honestly. Think about what you have available in your team. Think about how you can get people leveled up or whether you need to go outside of your team. Look at the full bill of materials for technology. So think about all the different moving parts that play into the data engineering process and think about what your priorities are. Leverage outside capabilities, particularly if you have things that are one-time or really specialized. So, I'll give an example. If you've got, you're not going to be doing the initial environment setup over and over again. So do you need to get your internal team all the way up to speed, or would you be better off hiring an external provider to either, provide that environment as a managed service or just help you get up and running and do some knowledge transfer to your team so you can get there faster? And then finally, get started. I think it's a good idea to start experimenting with new tools and with new techniques to kind of really get a feel for it and develop intuition around what it might look like inside of your organization. So we have about at least a few minutes for Q&A, and I see a couple of questions in here. First one is just, what are some of the pitfalls of building your own stack in-house? It really depends. I think this is where, the kind of honest look in the mirror comes in. So, think about what the skills are that are resident in your team. Think about what it is that you can get done and what your technology choices are. And then think about not just what it's going to take to get it up and running once, but think about retention of those people that have those skills, and think about the long tail of operations and maintenance that you're going to have to deal with. So, the pitfalls are, you run headlong into a brick wall because you don't have people that are good enough at tuning the JVM to get your Spark cluster working really well. And they don't know really how to read a stack trace. And, now you're kind of at an inroad you've kind of hit a hurdle that you can't get over, or that you're going to spend an inordinate amount of time on. The other thing is, think about where the value is for your organization, right? You can build your own stack, but what would those engineers be doing if they weren't building their own stack? Would they be building things that were more upfront connected to either top line or bottom line in the business? So, I think those are some of the pitfalls. Some of the benefits are, you kind of get the thing that you want. If you've got the right kind of team, particularly if you've got a team that can think in terms of platform, you could get something that's differentiating for you. If you've got, if you're in a data-oriented business and you've got the time, right? Because there's opportunity cost tied up in waiting to build your own stack. It's probably worth thinking about doing something else. Most important skills for effective data. So the next question is, what are the most important skills for effective data engineering? Are there programming languages that are must-haves versus nice-to-haves? So, here's kind of my current thinking on it. And this is, it really depends. If you're going to choose a proprietary stack, like, hey, we're going to do a lot of our stuff in Informatica, then Informatica skills are probably the most important thing. But, when you think about kind of broad generic skills, I think SQL is absolutely foundational to doing good data engineering. Having your engineers are going to need to be able to interrogate the data, understand what's in it, and think about how they need to transform that to get to the result that you need. So I think SQL is absolutely foundational. The thing I would layer in on top of that is probably Python. And the reason for that is Python's pretty flexible. It's pretty widely available, and a lot of platforms support it as a programming language. Again, that's where you start getting into like, okay, well, what's your technology stack look like? And then you might want to make choices that are a little bit closer to it. Like I said, we're sort of Spark oriented. Obviously, we do our internal developments in Scala, but for our customers, it's much more important that they have good SQL skills and good Python skills in-house. The other thing is Python is, it's pretty flexible. You can run it on a lot of different kinds of platforms. So you can also use it for scripting, kind of outside of the platform as well. So I think Python is just a good thing for folks to have in their toolkit when dealing with data. And there are a lot of great libraries out there that you can use in Python that are useful. So, I think from a programming language perspective, I think those are the big things. In terms of other skills, I think actually cloud infrastructure skills are really useful. You don't need your folks to necessarily be experts, but depending on what public cloud you're on, having someone on the team who's kind of conversant is really going to help with troubleshooting. So, if you get a particular kind of error back when you're trying to access an S3 bucket, right? Having someone on the team who just knows what that means and can say, oh, that's because we got the path wrong, or it's because, of, there's some kind of a consistency issue in the S3 bucket, and we can, wait 5 minutes and try again. That kind of knowledge is really, really useful. I would say that's probably the next biggest thing. And then the third thing I would say is data modeling and being able to think about how to structure data for analytics in a way that's smart. That's the kind of thing that I think folks can develop over time, but that is really handy to have inside the team. And let's see here. And then we have one more question that came in through the chat. Are you running Spark 3? Challenges and benefits of upgrading or not? And someone else wishing us well now that our WeWork location shut down and we need a new HQ. Thanks for that, I appreciate it. So we're not running Spark 3 yet. We're still running Spark 2.4.x. We're gonna probably transition to Spark 3 sort of early next year. It looks like there are some really neat things in there. I'm really interested in the catalog API, and we'll kind of see what we see, but we haven't made the transition yet. So for us, we're going a little bit slow just because there's not quite enough of a pull yet to make that transition. None of our customers are asking for it, and there aren't any features that are strictly kind of compelling us to go in that direction. But we're going to do that just because we like to remain current. But it's probably a kind of Q1 thing for us. So let's see if there are any other questions. Looks like no. All right, well, thank you very much, everyone. Thanks for joining. Really appreciate it. I hope this was informative. Please feel free to reach out if you have any questions or any follow-ups you would like. I'm glad to talk with folks who are sort of in the space and trying to figure this stuff out. Thanks a lot, everyone. With that, we'll sign off unless I don't think there are any other questions. Doesn't look like it. All right. Thanks a lot, everyone. Bye.